Howdy. So today I'm going to talk to you about the VESC. So what is the VESC? Well, the VESC, it's just a little circuit board basically. It goes between the battery and the motor and allows you to connect your controller. That's it. The question of what motor controller do I buy will come up. Now, your options in the market are go to the hobby store. Now, most people when they're building an electric skateboard, this is option one, go to the hobby store. Hobbyking.com, they sell motor controllers, very inexpensive. Now, most of the ones from the hobby store, the cheap ones, they will work, don't get me wrong, but there tends to be a few limits. So you can't use bigger voltages, much higher than about 24 volt or 6 cell batteries is about the limit, okay? So you're sort of stuck at this point if you use hobby grade stuff. And the problem with being stuck there is it's hard to make a really good electric skateboard when you're stuck with this level of stuff, you know. The main issues, the lower the voltage, or I suppose the other way of saying it, not having higher voltage tends to mean higher current throughput. So your system from your battery to the motor controller to the motor will have higher current draw. Now, for keeping it simple, once again, that means heat. Lots of heat. The heat builds up in the motor, builds up in the wires, builds up in the motor controller and in the battery. Heat is bad. You don't want heat. Now, if you know how to manage heat, maybe this is not a problem. You probably will learn what hill you can go up without overheating. You'll probably learn how many mates you can pull along behind you on your skateboard before it overheats. You know, what I used to do was just grab my motor and feel it. You know, every time I built a board with hobby grade stuff, that was my test. If I burn my hand, it's too hot. And eventually what sort of made me realize I can't use hobby stuff anymore was I would build a board for my mate. One of my mates, pretty big guy, and would go up a hill and, it's my phone ringing, go up a hill and things would melt, things would catch on fire, things would burn, and that's not cool. You don't want your skateboard catching on fire. Rule number one, no fire. Okay, so what was next? People that didn't want hobby stuff, what do they get? Well, this was sort of the next option that for a while there, like 2 years ago, was the go-to option for electric skateboard builders. Now, this is a motor controller made by Flyer. It's a Chinese-based company, an electronics company. They make motor controllers. That's what they specialize in. They make big ones for bikes. This is a small one. This will handle, they call it an 8S, up to 8S, and about 110 amps is what this one was rated at. Now, yeah, for some reason, there were reports of it not handling 8S. I never used it on 8S. My own setups, I would just use it at 6S. So that's 24 volts, guys. 24 volts, roughly. Let's just work with that. Now, the problem, once again, with lower voltage is current. Remember? Heat. Heat builds up in the battery, the motor controller, the motor. So that's a problem with this one. And the other problem with it was, you know, and I used to sell these. You know, this, in my opinion, was the best you could get out of the limited options. So this was the go-to motor controller. The problem was, though, it's not that reliable. You know, I don't know what happened, but I think at some point either the quality of the MOSFETs that were used, which you can see here, or just some of the parts were substituted, or, you know, I'm not sure, but quality really started going downhill, and yeah, it was a real big problem. And basically, we didn't have a choice. As electric skateboard builders worldwide, we had two choices. Hobby grade stuff from Hobby King, Flyer, which, like I said, I was selling it. There's in the UK, Alien. There was a few places, and it wasn't that reliable. So we needed something else, and that's when the VESC came along. Now, this is an old VESC that I just pulled out of my drawer. What makes the VESC so good? Well, firstly, the voltage. You can go up to 60 volts. Not that you would, but that's what the components are rated to. Most people, I think, would say the maximum voltage is like 12 cell battery. That's about as far as you would go. Even some people at 12S have reported problems. So for me, 10S is the limit that I'll go to, because I know it works perfectly at 10S, which is about 36 volts. Okay, let's work on that. Where 12S, you're basically adding like another 8 volts to that, so it's pushing it up high to its maximum limit that the components can handle. So with the electronics, you don't want to push that up there. Let's give it a little bit of room. Okay, so 36 volts, 10 cell battery is where to go at. Now the beauty of that is the current that comes from the battery into the motor controller, into the motor, is much lower, much lower compared to a 6 cell system. It could be half the amount on average of current running through it. So that means less heat. You can have smaller gauge wires, and electronics love to be cool. They don't like getting hot. So higher voltage is one of the really key things that got everyone excited when the VESC came along. But let's talk about the VESC. Where did it come from? It's not from the hobby store. Okay, it's not from a Chinese manufacturer. So where is it? It's from a guy called Benjamin Vetter. He basically designed this from scratch. His goal was to build the best motor controller. They're his words. I didn't make that up. That's what he wanted to do. The best motor controller. I think he's come pretty close. So yeah, he basically made it open source so that anyone could take the designs. So the layout of the PCB, you could go and manufacture that yourself. He tells you every single part that goes on it. So the MOSFETs, all these tiny little parts that are on there, everything he specifies. And the software that goes into the chip here, that is fully free, customized software that he's written just for this. So the whole thing, it's a customized motor controller. And a few members in the online forums found out about this motor controller, and they started contacting him and looking at making it. The problem with it, it's really, like, the parts on it are really expensive. The designer, like he said, he wanted the best motor controller you could make. So he went and bought all the best, like the chip, that's a powerful processor on there. High-end MOSFETs, high-end components, the shunts on here, it's all high-end stuff. You add up, like if you went and bought all these things to make one VESC, and well, you probably can't make one PCB, you sort of tend to have to make like 5 or 10. The total costs end up like, I don't know, about $150 of parts, and that's not even assembled. That's just a handful of parts and a printed circuit board, and then you've still got to work out how to get all the tiny little parts on there. So so that was the biggest problem. Everyone in the skateboard scene, the skateboard builders movement, knew that this would be a game changer, but trying to actually get the thing was difficult. That was the first speed hump to get this into the market for us guys, for builders of electric skateboards, because we want to build really good skateboards. That's all we want to do. We don't want stuff causing us problems. We don't want to have to be in the garage all the time. We want to be riding. We want to build a really good skateboard and just ride it. So yeah, that gives you a bit of an idea of the history of the VESC, and now times past, the last 2 years is sort of where this became something in people's minds. Now it's here. So yeah, a few of the quick specs. It's, like I said before, it's rated up to 60 volts, but you won't use it at that. It's just the rating of the components, and down to 8 volts is the lowest voltage. So you probably wouldn't use that level of voltage either. So they're your min and max. Ideally, I think 36 volt nominal batteries, which is about 42 volts. When that battery's fully charged, it's about 42 volts, and that's a safe working limit for this. Any higher than that, like a 12S battery, it can limit your options with the motor, and a lot of things like that can get very technical. We won't go into it, but yeah, so 10 cell is a great choice. In terms of current, it can actually handle a huge amount of current. 240 amps is what these MOSFETs are rated for as a burst of current. Now, you do not want to do that. That's ridiculous. An electric skateboard shouldn't use high current. In fact, one of the things that you should do when you build an electric skateboard is design it to use the lowest amount of, or not use, but draw the lowest amount of current possible. So the way you do that is your drivetrain has to be efficient. You need to calculate your wheel size, and you need to think about that, because you don't want to build a system that's going to draw really high amps and cook everything, overheat everything. So, but yeah, it can burst up to 240, but I would say the maximum that you should aim for in your electric skateboard is about 50 amps. Okay, you don't really want to go over that. That's enough. It's enough power to put you on your ass, basically. If you've built an electric skateboard and you've got it pulling that sort of power at that sort of voltage, man, it's powerful. It will get you going. It also has a built-in 5 volt output on it, which is really cool. So you can power external receivers. You could even power other things, like a little mini USB port, for instance, if you wanted to charge your phone or something like that. So the DRV chip, actually, yeah, it has that ability to output a lower voltage from what it receives from the battery, which, like I said, 36 volts, it can output 5 volts. So they're the basic specs. So what are the major benefits? What actually makes the VESC so goddamn bloody good for building an electric skateboard? I touched on it before, but the higher voltage. I won't go into it again, but that is number one. That's really important. Being able to run higher voltage, more efficient, lower heat, just better altogether. So let's leave that point there. Current control. Now, we did talk about current running from the battery through this into the motor, and how that can generate heat, and how you shouldn't exceed certain amounts of current. Well, the cool thing about the VESC is you can dial into the software. It's got a USB port here. You can plug it into your computer, go into the software and control the firmware, and tell the firmware that you do not want more than a certain amount of current going from the battery into the motor. And like I said before, 50 amps is about your limit. So you can go in and do that. If you've got 2 VESCs, 1, 2, you would go in and set 25 amps maximum on number 1, and on the slave you would set 25, because the total would be 50 amps. So that's a huge feature. Controlling the current is the number one key to a reliable system. Without current control, say if you've got this one from Flyer or a Hobby King, like a cheap $70 motor controller, there's no limit. If you get your motor jammed and you keep pulling the trigger on the throttle, the motor's job is to try to spin. Its job is to try to reduce the load on it, and it does that by pulling more current into it. And it will keep pulling current over and over and over again. It will increase until thermal shutdown, meltdown, fire. Basically, it will melt, it will short itself out, everything will catch on fire, essentially, with high current. So you need to be able to control the current from the battery through to the motor. The other reason that's important is because when you start researching battery technology, you'll start to know that batteries don't like outputting more current than what they're rated for. In fact, the lower current draw from a battery is optimal. You want to build a big battery and then only draw small currents out of it. That will improve longevity. It will just give you more capacity in each charge, basically. So having that control is really handy. You can tell it how much you want to come out of the battery and how much you want in the motor. It's controllable at both sides. So you can set the current for battery and max current for motor. You might have it lower for the battery. If you only have a battery that can output 20 amps, which, that's still enough. But if you don't want to exceed that, you tell the VESC 20 amps. That's all. The motor, in fact, this is like an inverter. It can control that current and voltage, and it can actually supply the motor with higher current only until it reaches a certain speed, a certain electrical RPM. So, which is good for when you're starting from a stationary spot. So your battery might only have a maximum of 20 amps. The motor can be set at 40 or 50. So initially you can get more current in your motor and not actually be pulling it out of your battery. Eventually that will equalize and they will both be about the same once you've reached a certain speed and a certain load. But yeah, it's just another really amazing feature about the VESC. So yeah, current control. So voltage, current control. The next thing, we've spoken a lot about heat, is the temperature control. This has a temperature sensor on the board near the MOSFETs, and it will actually, it will slowly shut the system down if the MOSFETs get too hot. I think the default setting is 80 degrees Celsius, so that's pretty hot. It's a good level. You don't want to exceed that, but it's also pretty high. The chances of reaching it, if you've got a good drivetrain and it's optimized, you're probably safe. You're not going to get there, but it's a safety mechanism. What that means is that you will not melt stuff. You will not short things out. Like if the wires get too hot, the insulation can melt on your motor wires and short circuit the whole system. And things just don't like getting hot on electronics. So that's built into it. And that's an advanced feature. Nothing that you can buy from the hobby store for $70 will offer you that. So it's a huge, huge feature. And it's why I love the VESC so much. Safety features. The other cool thing that probably doesn't get spoken about a lot is RPM limiting. That means you can basically get your motor to spin to a maximum level of RPMs. Why would you do that? In some cases, you actually don't want to go as fast as you possibly could. You might only want to go 20 kilometers an hour as a maximum. So that's pretty cool. That's advanced stuff. Why is it good for children? I would think for people learning. So you could have some really cool like software in the future that allows you to maybe program that with the touch of a button. So you might have a beginner mode or an advanced mode. So having it built into it now is great. And because this is open source, that means people can develop it later. So that's really cool. So RPM limiting. The other really amazing thing about this, and I don't use it on my normal builds because it's not needed, but it has sensor ports up here. So you can get motors that have Hall sensors in them, and it's basically 3 little sensors inside the motor. So they're positioned like, yeah, they're evenly positioned, put it that way. And it tells the motor controller the position of the motor when it's stationary and when it's trying to start up. And if the motor controller knows the position, it can control that motor better. So there's certain advantages of that. Now, the other thing that's really cool about the VESC, it actually is got some really advanced algorithms in it inside the chip here. And a lot of the motor controller, what makes it good are the algorithms, the software behind the hardware. And that's the same with anything, a laptop or Windows computers. The hardware is great, but you need software, right? So this has both the hardware and the software that are both very advanced. And the sensorless torque output on the VESC is unmatched. Nothing comes close to it. So what that means is you can have generally cheaper motors because they don't have these sensors in them, and you can get really good startup performance. In fact, so good that I probably will never put sensors on my brushless outrunner motors because I just don't think it needs it. It's another level of complexity, and it's more wires. You've got 5 extra wires running out of the motor into here, and they can disconnect, and let's keep it simple is my theory generally with building a good electric skateboard. Simple is good. But there are some motors that just won't work really well without sensors. If you watch my vlog from the other day, I've got these big 8-inch pneumatic hub motors, and they were terrible when I had them in without the sensor plugged in. But they already had the sensor in it, which was cool. All I had to do was just plug it in. The VESC is so smart that it could detect. I just went into the software and I just clicked a button, sensor mode, turned it from sensorless to censored, and it detects the sensors and records onto its memory the position of them. Bang, it's ready to go. And the performance improvements were, wow, mind-blowing. So this can do both. The other really cool thing about this, right? These 3 wires here are for connecting. Some people call them servo wires or whatever, but it's to connect a receiver from a normal remote control that you buy at your hobby store. Just a normal receiver. It connects there. But the other cool thing is you can actually connect into this port here a nunchuck, which it's like a wireless controller that you use on the Nintendo Wii. It's really cool. It's got a joystick on it. It's sort of perfect for electric skateboards, but this is natively compatible with that. You connect the pins up there. You can check out on the Electric Skateboard Builders Forum to see what pins to use, and there's pictures and there's big discussions on there about how to connect it. But it's a really cool way to control your electric skateboard. It's built into this. That's really cool. You can't necessarily do that with a motor controller, any other motor controller. You'd have to get another separate little circuit board, and you'd have to program that little circuit board in a particular way to decode the message and to send it into your motor controller. It's confusing. This natively supports it. So they're the few key features. So high voltage, awesome. Current control, awesome. Temperature control, RPM limiting, and different control options. So If you need to ask me more questions about the VESC, why it's so good, just write them down below and I'll answer them. Otherwise, buy your VESC, build a great electric skateboard. See ya.